One trick that hackers like to use is bit flipping, because bit flipping can actually shut down a computer and can corrupt data.
It was meant to send data, but what Voyager 1 transmitted feels more like a warning. After going completely silent for 5 terrifying months, this 47-year-old probe has finally started talking again, and what it's telling us is both fascinating and deeply unsettling. Stay tuned, because what you're about to discover will change how you look at the universe forever. The silence that terrified NASA. It's November 14th, 2023. NASA engineers are sitting at their desks, monitoring signals from the most distant human-made object in existence, Voyager 1. Suddenly, the data stream turns into complete gibberish. Not silence, but something far more eerie. Corrupted, meaningless signals that made absolutely no sense. For 5 agonizing months, this legendary spacecraft, humanity's farthest ambassador, was essentially lost in the cosmic void. Imagine the panic at NASA's Jet Propulsion Laboratory. Here's a probe that had been faithfully sending back data for nearly half a century, suddenly speaking in digital tongues. The terrifying reality hit them hard. Voyager 1 is over 15 billion miles away from Earth. That's so far that radio signals take 22.5 hours just to reach it, and another 22.5 hours to get back. If something goes wrong, there's no repair mission, no backup plan, no second chances. But here's where it gets really spine-chilling. The spacecraft wasn't completely dead. It was still receiving commands and responding with that steady carrier signal. It was like having a phone conversation with someone who could hear you perfectly but could only respond with random, terrifying whispers. NASA engineers knew they were racing against time. Every day that passed brought Voyager 1 closer to permanent silence as its nuclear power source continued to decay. The question that haunted everyone was simple yet horrifying. Had humanity just lost its only window into interstellar space forever? The breakthrough that changed everything. What happened next reads like a space thriller. NASA's brilliant engineers refused to give up. They dove deep into decades-old computer code, analyzing every line of programming that was uploaded to Voyager 1 back when disco was still popular and the internet didn't exist. The culprit? A single corrupted memory chip in the flight data subsystem, basically Voyager 1's computer brain. This tiny failure was scrambling all the scientific data before it could be transmitted back to Earth. But here's what's absolutely mind-blowing. NASA engineers had to perform brain surgery on a computer that's literally in another part of the galaxy. On April the 20th, 2024, after months of nail-biting tension, something incredible happened. The first coherent data in 5 months came streaming back from the depths of interstellar space. Engineers at Mission Control probably felt like they'd just heard the voice of a long-lost friend calling from the edge of forever. But the real breakthrough came later. By June 2024, all of Voyager 1's science instruments were back online, ready to continue their cosmic investigation. The probe that had been declared nearly dead was suddenly very much alive again, and what it started sending back would make scientists around the world lose sleep. The recovery was a testament to human ingenuity and our refusal to let go of our connection to the stars. But as we'll discover, getting Voyager 1 back online might have been the easy part. Whispers from the cosmic void. Now here's where things get really interesting, and honestly, a bit unsettling. Since coming back online, Voyager 1 has been detecting something that doesn't quite fit our models of what interstellar space should be like. Scientists have been analyzing a persistent, low-frequency hum coming from the plasma waves in interstellar space. Think of it like the universe's background music, except this tune is unlike anything we expected to hear. Some researchers describe it as a cosmic whisper, a faint but constant signal that seems to pulse through the fabric of space itself. But that's not all. The data show unexpected variations in magnetic fields and particle densities that suggest interstellar space isn't the empty, uniform void we once thought it was. Instead, it appears to be a dynamic, ever-changing environment with structures and phenomena we're only just beginning to understand. Here's what's keeping scientists up at night. Could these signals indicate that Voyager 1 is encountering something completely unprecedented? Are we detecting natural cosmic phenomena that our theories never predicted? Or could there be something more profound at work? Some researchers are asking questions that venture into speculation territory. The patterns in the data don't always match what our current models of interstellar physics would predict. Is it possible that interstellar space contains structures or energy sources that we've never encountered before? The most intriguing aspect is how these signals seem to change over time, almost as if they're responding to Voyager 1's presence or following patterns that suggest a level of organization that purely random cosmic processes shouldn't produce. The thruster crisis and its terrifying implications. While scientists puzzle over mysterious signals, Voyager 1 faces a more immediate crisis that could end its mission entirely. The spacecraft's attitude control thrusters, the tiny engines that keep its antenna pointed toward Earth, are slowly clogging up. The problem is silicon dioxide buildup, essentially space rust forming inside the thruster tubes. As these crucial systems fail one by one, Voyager 1 is gradually losing its ability to communicate with home. It's like watching someone slowly lose their voice while they're trying to tell you something incredibly important. Here's the terrifying part. NASA engineers estimate that Voyager 1 might only have until around 2025 to maintain reliable communication. After that, the probe could still be functional, still be collecting data, but unable to share its discoveries with Earth. Imagine the cosmic irony, humanity's greatest explorer sailing deeper into the unknown than any human creation has ever gone, potentially discovering incredible secrets about the universe but unable to tell us what it finds. It would be like having a time traveler who can see the future but can't speak. But there's another chilling possibility that keeps mission planners awake at night. What if Voyager 1's thruster problems aren't just mechanical failures? The spacecraft is operating in an environment that no human technology has ever experienced before. Could the mysterious phenomena it's detecting actually be affecting its hardware? Some engineers have noted that the thruster degradation doesn't follow the exact patterns they predicted based on Earth testing. The interstellar environment might be more hostile to our technology than we ever imagined, slowly but steadily corrupting the very instruments we need to study it. The race against time and cosmic darkness. Right now, as you're watching this video, Voyager 1 is speeding through interstellar space at 38,000 miles per hour, carrying humanity's hopes and dreams into the cosmic dark. Every day, it travels 900,000 miles farther from home, a distance that would take you more than 35 trips around Earth's equator. The probe's radioisotope thermoelectric generators are steadily weakening, losing about 4 watts of power each year. NASA has been strategically shutting down non-essential systems to keep the science instruments running, but time is running out. By 2030, Voyager 1 will likely go silent forever, its voice joining the cosmic quiet that surrounds it. But here's what makes this race against time so compelling. Every piece of data Voyager 1 sends back is potentially the last of its kind for decades, maybe centuries. We're watching the final chapters of the greatest exploration story in human history unfold in real time. The data coming back now is more precious than gold. Each signal represents humanity's only direct observations from interstellar space, our only real-time connection to the realm between the stars. When Voyager 1 finally falls silent, we'll lose our eyes and ears in this alien domain, possibly for generations. What makes this even more poignant is that Voyager 1 was never supposed to last this long. Designed for a 4-year mission to study Jupiter and Saturn, it's now operating 12 times longer than planned in an environment its creators never imagined it would reach. Every day it continues working as a gift, every signal a message from the edge of human experience. but every day also brings it closer to that final moment when its voice will fade into the eternal silence of space. What the data really means for humanity. So what do these mysterious signals and unexpected discoveries actually mean for us here on Earth? The implications go far beyond simple scientific curiosity. They touch the very core of how we understand our place in the universe. First, let's talk about what we're definitely learning. Voyager 1's data is rewriting our textbooks about interstellar space. The region between stars is a complex, dynamic environment filled with magnetic fields, plasma waves, and particle interactions that create a kind of cosmic weather system. The persistent hum detected by Voyager 1 tells us that interstellar space is alive with activity. These plasma wave emissions create a constant background noise that permeates the galaxy. Imagine it as the universe's heartbeat, a rhythm that's been pulsing for billions of years, and we're finally learning to listen. But here's where things get really thought-provoking. Some of the data patterns don't match our current theories perfectly. Scientists are finding structures and phenomena in interstellar space that our models didn't predict. This could mean one of several things, and each possibility is fascinating in its own way. Maybe our understanding of plasma physics in extreme environments needs major updates. Perhaps interstellar space contains types of matter or energy that we haven't discovered yet. Or possibly there are processes occurring on galactic scales that we're only now beginning to detect. The most intriguing speculation, and yes, this is speculation, is whether some of these organized patterns could indicate natural phenomena that are far more complex than we imagined. Could interstellar space contain self-organizing systems? Natural processes that create order from chaos on scales we've never considered? The legacy and the questions that remain. When Voyager 1 finally falls silent, it won't disappear. This remarkable machine will continue its journey through the cosmos for millions of years, carrying with it the famous Golden Record, humanity's message to the universe containing music, greetings, and sounds from Earth. But the scientific legacy is what truly matters. Every byte of data Voyager 1 has transmitted back represents knowledge that no other spacecraft has ever gathered. It's the only probe to directly sample the interstellar medium, to measure the magnetic fields between stars, to detect the cosmic ray environment beyond our solar system's protective bubble. The questions Voyager 1 has raised are perhaps more important than the answers it's provided. Why is interstellar space more dynamic than we expected? What creates these organized patterns in the cosmic plasma? How do magnetic fields behave on interstellar scales? And here's the big question that keeps space scientists up at night. What else is out there that we haven't detected yet? If Voyager 1 has found this much complexity in just a tiny sample of interstellar space, what incredible phenomena might exist in the vast regions it will never reach? The probe's discoveries have already influenced how we design future missions. NASA is planning new interstellar probe concepts that could follow Voyager's path, equipped with modern instruments that could unlock even more secrets of the space between stars. But those missions are years, maybe decades away. Right now, Voyager 1 is our only ambassador to interstellar space, our single point of contact with the realm beyond our solar system's influence. The temperature mystery that defies physics. Here's something that will absolutely blow your mind and has left physicists scratching their heads for months. Voyager 1 instruments have been detecting temperature readings in interstellar space that don't match any of our theoretical predictions. We're talking about variations that suggest pockets of space that are either much hotter or much colder than they should be. The cosmic microwave background radiation gives us a baseline temperature for the universe, about 2.7 degrees above absolute zero. But Voyager 1 has been finding regions where the plasma temperature spikes dramatically, sometimes reaching thousands of degrees, then dropping back down for no apparent reason. What's causing these temperature anomalies? Some scientists speculate about invisible shockwaves from ancient stellar explosions still rippling through space. Others wonder if we're detecting the afterglow of cosmic events so massive and so distant that we can't even imagine what caused them. But here's the really spine-tingling part. These temperature spikes seem to follow patterns. They're not random fluctuations. There's an almost rhythmic quality to how they appear and disappear. It's like the universe has a fever that comes and goes in waves, and we have no idea what's causing the cosmic illness. Could these temperature mysteries be our first glimpse of dark matter interactions? Are we witnessing the thermal signature of phenomena that exist beyond our current understanding of physics? The questions are as hot as the unexplained temperature spikes themselves. The magnetic field maze Voyager can't escape. If the temperature mysteries weren't enough to keep you awake at night, wait until you hear about the magnetic field nightmare that Voyager 1 has stumbled into. The probe's magnetometer has been detecting something that shouldn't exist. Twisted, interconnected magnetic field lines that seem to form a kind of cosmic labyrinth. Think of it like this. Imagine you're walking through a maze, but instead of walls made of stone or hedge, you're navigating through invisible magnetic barriers that stretch for billions of miles. That's essentially what Voyager 1 is experiencing right now in interstellar space. These magnetic field structures are massive. We're talking about formations that could dwarf entire solar systems. But here's what's truly unsettling. They seem to be guiding Voyager 1's path through space, almost like invisible hands steering our probe in directions we never intended. The magnetic field readings show sudden twists and turns that don't match our models of how galactic magnetic fields should behave. It's as if space itself has a hidden architecture, a secret blueprint that we're only now beginning to glimpse through Voyager's instruments. Some researchers are asking uncomfortable questions. Could these magnetic highways be natural, or do they suggest that interstellar space has been organized somehow? Are we looking at the cosmic equivalent of traffic lanes, channels carved through space by forces we don't understand? The most disturbing possibility is that Voyager 1 isn't just observing these magnetic structures. It might be trapped by them, unable to break free from invisible fields that are slowly but surely altering its trajectory through the cosmos. The particle storm that shouldn't exist. Just when scientists thought they had a handle on Voyager 1's discoveries, the probe detected something that has turned our understanding of interstellar space completely upside down. Particle storms of incredible intensity appearing in regions that should be nearly empty. We're not talking about the gentle solar wind that we know and understand. These are torrents of high-energy particles, electrons, protons, and heavier atomic nuclei, streaming through interstellar space at velocities that approach the speed of light. The energy levels are so high that they rival the most powerful cosmic ray events ever detected. But here's what makes these particle storms truly terrifying from a scientific perspective. They appear out of nowhere, last for weeks or even months, then vanish completely, leaving behind no trace of what caused them or where they went. The particles themselves tell a strange story. Their isotopic signatures don't match anything we'd expect from known sources like supernovae or neutron stars. It's almost as if they're being manufactured somewhere in the depths of space by processes we've never encountered before. Some of these particles carry so much energy that they could pose a serious threat to any future spacecraft trying to follow Voyager's path. We're talking about radiation levels that could fry electronic systems in minutes and pose deadly risks to human astronauts. The timing of these storms is perhaps the most puzzling aspect. They don't correlate with any known cosmic events, no nearby stellar explosions, no black hole activity, nothing that would explain such massive energy releases. It's like the universe is firing invisible cannons, and we can only detect the bullets after they've already been shot. Could these particle storms be connected to the magnetic field maze and temperature anomalies Voyager has been detecting? Are we witnessing different aspects of the same cosmic phenomenon? Something so vast and complex that we can only see tiny pieces of it at a time. The countdown to cosmic silence. Voyager 1 is nearing the end of its journey as NASA struggles to balance dwindling power, shutting down instruments to keep the probe alive a little longer. Its heaters are already off, leaving some instruments frozen in the deep cold of space. yet it continues sending back data from interstellar space. Each watt of electricity has become precious, forcing heartbreaking choices as the spacecraft weakens. The tragedy is that Voyager 1's greatest discoveries may be happening now, just as its systems are failing. Engineers have set up fault protection routines to keep it running even after Earth can no longer command it, like digital life support for a fading mind. Still, the risk remains that it could detect something revolutionary but lack the power to fully transmit the findings. Its data reveals interstellar space as a place far stranger and more dynamic than once imagined. Plasma waves, magnetic fields, and particle storms show that our galaxy is not empty, but an active, interconnected system. These discoveries suggest we've only glimpsed a fraction of the cosmic reality, much like mistaking a single drop of water for the whole ocean. Voyager 1's legacy will outlast its fading signal. The data it has gathered will be studied for decades, shaping how we search for life and explore the universe. More importantly, its silence will not mark an ending but a beginning, inspiring future missions to unlock the deeper mysteries of our galaxy and beyond. Voyager 1's revival after months of silence stands as a testament to human ingenuity and the probe's enduring legacy, as it continues sending back rare signals from the edge of interstellar space. Its discoveries, plasma waves, magnetic structures, and unexplained phenomena reveal a cosmos more complex than our theories can fully explain. Though its power wanes with each passing year, every transmission remains a priceless whisper from the farthest reaches of human exploration, deepening our understanding of the galaxy. What do you think about these mysterious signals from interstellar space? Could there be something even more extraordinary waiting to be discovered? Don't forget to like and subscribe to our channel. Thanks!